Hope you understood the insertion operation on singly linked list. Let us discuss the deletion operation. There are three cases in performing the deletion operation. We can remove the first element, we can remove the last element, and also we can remove any other element. Right. Take an example of a linked list with three nodes. With the first node, as usual, we are referring with the name head. The last node, we are referring with the name last. Hope you understood the insertion operation on single linked list. Let us talk about the deletion operation. There are three cases in deletion operation. We can remove the first element, we can remove the last element, we can remove any other element. Let us discuss the removal of the first element. Take an example of a linked list with the three nodes. As usual, we are referring the first node with the name head, the last node with the name last. Here, what we will do is we need to remove the first element, that is the head element. Simply, we can't remove the head node because if we remove the head node, it is impossible to track the linked list. So what we will do is we'll take a temporary pointer and we'll store the address of head into the temporary pointer. Now we'll move head to next node, that is head equal to head arrow next. By doing that, we are moving the head from the first node to second node. Now, after that, simply we can remove the temporary node by using free of temp. Let us see the implementation of deleting the first node. Now, initialize the head node to temp node, move temp to second node, and remove the memory which is allocated for temporary node. This is the removal of the first node. Let us discuss the removal of the last node. So take an example of same linked list with the three nodes, where the first node referring with the name head and the last node referring with the name last. Here what we need to do is we need to identify the last before node. That we can do starting from the first node. The first node is the head node that I am making as the temporary node. Now here what I'll do is just I am iterating this temp till the end of the list. This is not the end, hence I'll move temp to next node. So whenever I'll moving temp to next node, I'll store the information in temporary pointer, that is previous. Again, here this is not the last node, then again I am moving temp to next node and storing that information into previous. Now here this is the last node, so here I'll stop it moving the temporary pointer. So this is the temp node and as well as this is the last node, whereas this node is the previous node. Now what I'll do is I'll move the last pointer to previous. Now moving the last pointer to previous pointer, that means the previous location, and then this node becomes the temporary node. Now simply I can remove this temporary node. After removing this temporary node, this becomes your last node. So this is the procedure to remove the last node in linked list. Let's see the implementation. Till you reach end of the list, store the information of temp into the previous and move temp to next node. Now here what I am doing is I am moving the last to previous node. Now let us discuss the removal of any given element. Take an example of a linked list of 4 nodes. First node head as head node, the last node as last. Suppose delete an element 30. So for that, you need to make a search to find the element 30, starting from the first node. So this kind of the search we can do only with the help of the temporary pointer, because you need to search the data value of each and every node. What is temp arrow data? Temp arrow data is 10, which is not equal to 30. Then make a move. Now, whenever you are making a move to the next node, store the information in the variable previous. Now this becomes your temp. What is temp arrow data? Temp arrow data is 20, which is not equal to 30. And again, make a move. Now, this is your temp. Before moving temp to next node, store this information into previous. So, this node name is previous. Now, this node name is temp. and this node name is, which is next to temp, hence called as temp arrow next. Now the node is this node which you want to delete from the list is temp. Now here, after removal of this node, there is a link, there should be a link between this temp and temp arrow next. So not temp, this is previous, previous and previous, temp arrow next. So hence give an assignment like previous arrow next equal to temp arrow next. Now a link is established between this node 20 and the node 40. Then you can simply remove this node by calling free of temp. This is the procedure to remove any element in the given list. Let's see the implementation. Just read the key which you want to remove. Now start from the head node till you reach end of the list. Search for the given key value. If you are able to locate that key value, come out of the loop, or otherwise store the information in previous and make a move of temp to next node. Now just give a link between the previous and temp arrow next. Let's execute the deletion operation. Add deletion functions, function declarations. Delete beginning. Delete last element. And delete any given element. Let's add them to menu options. Now take the option as 7. Delete begin. And option 8. Delete end. And option 9. Delete. Now add them to cases. Case 7. Del underscore begin. Take a break. Case 8. Del underscore end. And then take a break. Case 9. Deletion. Just a break. Now write implementations for each deletion function. Del underscore begin. Remove the first element from linked list. So for that, take a temporary pointer, temp equal to head. Move temp to next node, temp equal to temp arrow next. And then simply deallocate the memory for temp by using free of temp. This is the removal of the first element. Simply you remove the last element. Void del underscore end. Now here again, starting from the first node, temp equal to head, while temp not equal to last till you reach end of the list, store temp information into previous and move temp equal to temp arrow next. Now here what I'll do is I'll move last to previous node, last equal to previous node, and then simply you can remove temp, free of temp. Now remove any given element. So for this you need to read some data value, printf, enter value to remove. And then read that data value, scanf %t ampersand x. Now again start search for that element from the first node, temp equal to head, while temp not equal to none. Here what I am doing is I'm checking if temp arrow data equal to key. If temp arrow data equal to key. then take a break, or otherwise store temp into previous and then make a move of temp. Temp equal to temp arrow next. Now we have located the value which you want to remove from the list. Just simply adjust pointers temp arrow next equal to temp arrow next. Now you can deallocate memory for temp. Let's see the execution. Whereas deleting a last node, you need to make the last next pointer should hold the null value, which is very important here. Let's see the execution. Just create a single linked list with 5 data values 10, 20, 30, 40, and 50. Now this is your linked list. Let's perform the deletion operation. The first one is to remove the first node, first element from the linked list, which I have given under case 7. Now, after executing that begin function, let's display the elements. You see here, the first element got removed from the linked list. After removing the first element, these are the remaining elements in the linked list. Let's start giving the another option 8, which is to remove the last element from the linked list. Let's see the contents after removing the last element. The last element is 50. After removing 50, these are the remaining elements in the linked list 20, 30, 40. Let's see the implementation of deleting any given element. Try to enter a value to remove. Here I am giving the element as 30. You see the contents after removing 30. You see here, after removing 30 from this list, we are remaining with the 2 elements, that is 20 and 40. This is an implementation of deletion operation on single linked lists.